Professor R. Ashokamani, Director, Research and Development, Dhanalakshmi College of Engineering, Tambaram, Chennai. He is former professor and head of the department, Physics, Anna University, Chennai. He is presently guiding 3 research scholars. He has more than 44 years of UG and PG teaching experience and 33 years of research experience. 14 research scholars have obtained doctorate under his guidance in the area of material science and solid-state physics. He has more than 150 research publications to his credit, of which 90 are in international journals. He has authored a book on solid-state physics, which is an international publication. He has participated in several international conferences, both in India as well as in foreign countries such as USA, UK, France, Germany, Italy, and Yugoslavia. He has been a guest scientist at ICTP, Italy, several times. He is a fellow and treasurer of Tamil Nadu Academy of Sciences.
Welcome to the UGC lecture series in applied electronics. This lecture is intended for the students of semester 4 who are having a course on basic physics, and the first chapter in this paper is on optics, and we have been seeing a course of lectures on interference. We went through aberration in mirrors and lenses in detail. We are going through now a set of lectures in interference, and the lecture number 12 will consist of the following subsections, namely coherent sources, conditions for constructive and destructive interference, change of phase due to reflection, interference in thin films. And in the last lecture, we were seeing how the surface of a pool of water will be disturbed when we drop a stone. Supposing you drop a stone in a pool of water, the water surface gets disturbed and you get a wave pattern. You get a wave, right? You got a mechanical wave. Light waves, as we said in the previous lectures, is also it is traveling in the form of waves, the transverse waves. And I also told you in the last lecture, there is a conflicting idea between Newton and Huygens. According to Newton, light travels in the form of rays, but according to Huygens, light travels in the form of waves. The light coming from a source, I got the light sources here in this camera room, and these light waves which are hitting my eyes are supposed to travel in the form of waves according to Huygens wave theory. Now, you should all remember now onwards the wave theory is important, because without the wave theory you cannot explain the phenomenon of interference. Similarly, the phenomenon of diffraction, about which we will be talking in the days to come, and polarization. So, these phenomena of interference, diffraction and polarization can be understood or can be explained only on the basis of wave theory of light. So, in the case of mirrors and so on, now the Newton's theory can hold good, but when you go to these phenomena, the wave theory has to be necessarily introduced to explain these phenomena. Okay. So, we are talking about mechanical waves, and whatever I am telling about mechanical waves hold good for the light waves also. To understand the phenomenon of interference, I am showing you the slides. In this slide, instead of one disturbance, instead of one stone being dropped in a pool of water, I have got 2 stones dropped simultaneously in a pool of water, as a result of which waves will be generated, and you see the waves coming from the point of disturbance, they are moving towards the shore, and another set of waves coming from the second stone, the second point of disturbance. This is a point at which disturbance starts, it spreads, the wave is going in this direction. And what is interference? You produce two waves and make them to interfere, to make them to meet each other. They are meeting or interfering with each other, and what you want to find out is the resultant. What happens to when two waves are meeting each other? What happens to the resultant? What happens to the net effect? The net effect, as I told you, if two waves are meeting in such a way that what could happen is the two waves can interfere either constructively or what destructively. Either you can have constructive interference or destructive interference. We will see in today's lecture what do we mean by coherent sources, what kind of sources you should be having to have constructive interference, and then what is meant by path difference, phase difference, and so on. So, we now see two waves which are being propagated from the point of disturbance, and you have a point A as well as a point B. You can have the point A where a wave meets another wave, the two waves meet each other in such a way that the crest of the first wave meets the crest of the second wave. When the crest meets another crest, what will happen? The two amplitudes will be getting summed up, the resultant will be 2A. If the two crests meet, the crest meeting a crest will lead to constructive interference, the amplitude will be getting summed up, A plus A will be 2A. That is what is happening at the point A. Point A refers to the crest meeting a crest or a trough meeting a trough, giving rise to constructive interference. At a point A there occurs constructive interference. Note that two regions, A is the point where there is a constructive interference, whereas at the point B there is a destructive interference. What do you mean by destructive interference? When will you get destructive interference? If the wave A, the crest of the wave A and the trough of the wave B, if they overlap each other, if they meet each other, the crest will annul the trough, both of them will be annihilated. As I told you in the last lecture, if a crest meets a crest or a trough meets a trough, in both cases A plus A will be 2A or minus A plus minus A will be minus 2A. In both cases there will be constructive interference. On the other hand, if A and minus A plus minus A will be 0. Okay. So, one leads to a displacement upward, the other leads to a displacement downward. The upward and downward displacements will cancel each other and leading to what is called destructive interference. That is what is happening at the point B. Okay. That is what I have been telling you. Now, let me ask you a question. If you have got a source, a single source, a light bulb, okay, you have a light bulb, whether a light bulb will be able to give the interference pattern, or can it be called as a coherent source? What do we mean by coherent sources? Therefore, you can have a monochromatic light source at this point. From one light source, yes, now you have two sources S1 and S2. By making the light to be incident and made to pass through two slits, this is a famous Young's double slit experiment. So, from a single source, yes, you get now sources S1 and S2. What are S1 and S2? The light that is being propagated, that is being passed through a slit opening here and another slit that is opening here. The two slits are there, two openings are there, and light passing through the two openings, they act like two independent sources S1 and S2. But even if I say two independent, it is important to note that the phase difference or the two sources will be in phase with each other. In phase with each other, what I mean is, if a crest is coming at this point, emitted from this point, a crest will be emitted from this point also, from this source also at the same time, because the light is coming from the common source. Yes. So, there will be no phase difference between the waves emitted from the source S1 and the source S2. Crust is coming from here, a crust also will be coming from here. So, when you got a crust here, then a trough here, crust here, trough here and so on, there will be, you have a crust here and there is a crust here, you see a crust here, crust here, a crust here, crust here. These two will meet each other, leading to what is called constructive interference. You have got a screen here. On the screen, what you see, you have a bright line or a bright. Now, you got a slit here, opening here, opening here. You get a bright line here, that you call as a constructive interference. Why do you say it is constructive? Because the two crusts meet each other. You got a crust here, crust here. On the other hand, you see here at this point, a crust is here. What do you observe here? You observe a trough. Okay, this is a point. This point is important. You got a crust here. At this point, you have a trough. Again, there is a crust here, trough here. So, when a crust meets a trough, crust is a positive displacement, trough is a negative displacement. The positive and negative will annul each other. They will be completely annulling each other, provided the amplitudes of the two are equal. One is positive, the other is negative. They are equal or opposite. This is plus A, this is minus A. Displacement caused from the equilibrium position. This is minus A, this is plus A. Okay, this is the equilibrium position. This is plus A, this is minus A. These two will combine. When plus A and minus A, when they combine, the resultant will be 0. That is what you are having here. So, leading to what is called destructive interference. And again, you have got constructive interference. The intensity will be equal to 0. What is the relation connecting the resultant intensity and the resultant displacement? If the resultant displacement, as I told you, A plus A 2A, 2A square will be equal to the intensity. Again, if you say minus 2A, minus A added with minus A, when does it come minus A being added to minus A? When two troughs are coinciding, A and minus A, then the resultant displacement will be minus 2A, but the intensity will be minus 2A to the power of 2. Again, it will be 4A square. Whether it is crust is meeting a crust, 2A whole square, whereas a trough is meeting a trough, minus 2A whole square. In both cases, the intensity will be 4A square. On the other hand, if a crust and trough, if they meet, plus A and minus A will be equal to 0. So, the resultant intensity also will be equal to 0, because the displacement is 0. So, the intensity should be equal to, necessarily be equal to 0. If a trough is meeting a trough, there will be a constructive interference. If crust and trough meet, then that will lead to a destructive interference. The amplitudes are equal, the resultant will be equal to 0 in the case of a destructive interference. Now, there are the basic things you should know. So, the Young's double slit experiment shows how you get the bright fringe, okay, a dark fringe leading because of the destructive interference. Then you got a bright fringe because of constructive interference and so on. Alternately, you get a bright and dark lines. This you call as a interference pattern, and this pattern that is obtained by Young in his famous Young's double slit experiment can be explained only on the basis of wave theory. So, let us go to understand what are coherent sources. As I told you, the S1 and S2, the sources which are produced here by making light to travel through the two slits, these two sources are coherent sources because of the reasons which I will be giving now. What do we understand by coherent sources? In order to observe a stationary set of a pattern of consisting of bright and dark fringes, as I showed just now, the sources must be having the same wavelength. Is it satisfied now? It should be monochromatic. Same wavelength means because these two sources S1 and S2 are coming from the source S. Obviously, if S is monochromatic, S1 and S2, these two sources will also be monochromatic, and the wavelength of this and the wavelength of this also will be same, okay, because they are coming from the same monochromatic, same source having a wavelength lambda. Therefore, S1 and S2 will be coherent, and again the phase difference between these two should be either constant or 0. So, phase difference should be, they must maintain a constant phase difference, constant phase with respect to each other, either a phase difference or a constant phase, both are the same. Constant phase means when a crust is coming at a particular point from source S1, again a crust should be coming. If a trough is coming, same trough, another trough should be coming, not a crust. If a crust comes, it will lead to a destructive interference. Okay. So, they must maintain a constant phase. So, there are two types of interference, as you all know by now, constructive interference and destructive interference. This is a question that I raised just now, whether a light coming from a bulb, you have a source here, light coming from a bulb, will it lead to an interference pattern, whether the bulb will lead to a interference pattern, it may be monochromatic light. But the point is, you should have two slits. So, from a single light source, you will never get an interference pattern. You should allow two waves to interfere with each other, and the two sources should be having same wavelength. Further, the phase difference should be the same. It may be, the phase difference may be, should be constant or 0. Okay. So, light coming from an ordinary bulb, it may be a monochromatic source, but it may not lead to interference pattern. Now, you see here light coming from two slits. Okay. You got a light coming from two slits. If light waves did not spread out after passing through the slits, no interference will take place, right. It will be spreading. So, what do you understand from this? The width of the slit should be narrow, it should not be very broad. The width of the slit should be narrow, so that the waves diverge, right. So, if light waves did not spread out after passing through the slits, no interference will occur. That means, the two sources should be closer to each other, the two slits should be close to each other. Again the width should be also should be narrow. The light waves from the two slits overlap as they spread out, filling what we expect to be shadowed regions with light after, and producing interference fringes on a screen placed on the right of the slits. So, you see here, compared to this, here the two sources, the two disturbances which are coming through this slit and this slit, they meet each other, the waves interfere with each other, depending upon the fact whether the crusts meet each other or the troughs meet each other, there will be constructive interference, or a crust and trough meet each other, there will be destructive interference. So, the narrowness of the slit and also the two slits should be closer to each other. I will come to that point little later again. At a beach in Tel Aviv, Israel, plain water waves pass through two openings in a break wall. You see a wall here, break wall, you have got a wall here, you have got an opening here, there is another opening, you see water waves coming through this, and water waves coming from this opening also. There are two openings, you see opening here, you see the spreading of the waves, right. You see the spreading of the waves, and they will interfere with each other. The waves exit at the openings with circular wave fronts. Notice how the beach has been shaped by the circular wave fronts, and you go to the beach, as I told you in the last lecture, you can see the beautiful destructive and constructive interferences. What I would like to tell you is, you may sit near the seashore, you may be getting a big wave, a wave with a large amplitude, and you may expect the wave to come and touch your feet, but it does not happen, because the fact that the wave that came earlier, it goes back and then destroys the incoming wave. Even though the amplitude is large, the wave that is going back, it annihilates or it brings the displacement downward, right. So, that will be an example of a destructive interference. So, you can go to the beach and see them constructive and destructive interference, at least the destructive thing you can see. Okay. Once again the same thing I am showing the mechanical waves produced by in a surface of a pool of water, and this is what I showed you, the Young's double slit experiment, wherein from a single source you got a barrier giving rise to two sources S1 and S2. The light coming from the source S1 is spreading like this, S2 will be S1 is spreading like this, S2 will be spreading in this direction, and depending upon the fact that the crust is meeting a crust, then you get maximum displacement or maximum amplitude or the intensity. In this case, the crust and trough meet each other, the resultant intensity will be 0, because the resultant intensity is 0, you got darkness, right. You got a dark band, because the resultant intensity is 0. The maximum intensity will give rise to a bright fringe, you got a bright fringe. The minimum intensity will give rise to a dark fringe, another maximum intensity will give a bright fringe. So, you get a set of bright line, dark line, bright line, dark line. A set of lines you are getting alternately bright and dark line, this you call as the interference pattern. Now, we have to pass on to this kind of interference patterns obtained by different methods. I will be talking about air wedge and the rings which are obtained by Newton, so called Newton's rings and so on. So, anyway, the point is you have got you should have two sources having the same wavelength and a constant phase difference, that is important, right. Then only you will be getting the set of pattern that I am showing, the alternate bright dark fringes. Okay. So, this is an example of a constructive interference once again, wherein you find that you got two slits S1 and S2. Okay. You see a crust here, what do you see here? Crust here, right. A crust is meeting a crust, then that will give rise to a bright fringe, as I showed you earlier. Then you go to the second case, when will you be getting bright fringe? What is the other condition? A trough should be meeting a trough, that is what you observe here. A trough is meeting a trough, okay. A trough meeting a trough here, okay. Then also you will be getting a trough meeting a trough meeting a trough, okay. And it is equivalent to telling that the crust will be meeting a crust, okay. Obviously, that should be the case. So, that will lead to a bright fringe once again. So, a crust is meeting a crust or a trough is meeting a trough, these two will lead to constructive interference. On the other hand, what is the other possibility? Crust is meeting a trough, that is the third case, that is the crust is meeting you see a crust here, you see a trough here, trough is meeting a crust. So, if the trough and crust meet each other, that will lead to the displacement 0 here, that will lead to a dark fringe. Then a path difference of lambda, what is my path difference? The additional distance travelled by one of the light beams compared to the other beam. You see here, you have got this you can have as capital D, you have a light ray here, okay, coming here, light ray from some other point goes here, there will be some point P. Supposing you have got S1 P. So, S1 is far away from here, right, S1 is far away from here, S1 P will be nearer, S2 is from somewhere here, S2 P and S1 P need not be equal. So, depending upon the location of S1 and S2, S1 P and S2 P will be different. The difference between S2 P and S1 P, the difference or extra distance travelled by one of the light beams compared to the other light beam is called the path difference. What is path difference again? The extra distance or the additional distance travelled by one of the light beams compared to the other light beam will give you what is called the path difference. And in this path difference, there will be one full wave, that is one full wave is lambda. So, a path difference contains 1 lambda or 0 lambda, 0 means path difference is 0 or lambda is 1 full wave, right. So, if the path difference is 0 or lambda or 2 lambda or 3 lambda, they refer to the fact that the interference will be constructive, because 0 or lambda or 2 lambda, if the path difference is 0 or lambda or 2 lambda, there will be constructive interference. On the other hand, if the path difference is lambda by 2, what do you mean by lambda by 2? If there is a crust is here, trough will be here. So, this is what is lambda by 2? Half wave, this is equal to this entire thing is full wave, right. You have got a start from here, a crust is here, trough is here, this is lambda, or in other words the distance separating the crust and crust, the crust is here, that is also lambda, trough and trough is lambda, one full wave is lambda. You see here the you take this point and this point. Now, what is the path difference between this and this? Now, you have a crust here, you have got a trough here. Now, the path difference is lambda by 2, right. You should understand this is a half wave, right. The wave starts from here, okay. You got the path difference is lambda by 2, then that will lead to destructive interference. Okay. So, a path difference of lambda will be equal to a phase difference of 2 pi. This is a very important point. A path difference lambda will be equal to a phase difference of 2 pi. So, now you go to another section which is again important, which will be made use of in the sections to come when we are discussing about air wedge or Newton's rings. So, that is the reason why we have to go to the change of phase due to reflection. Let us go to the summary part. The issues which we have been discussing are: number 1, when two waves interfere with each other, either there will be constructive or destructive interference. For interference to occur, the two light sources should be coherent, and lastly there will be constructive interference if the phase difference is 0, 2 pi or 4 pi. 2 pi means one full wave, or 0 means no phase difference at all. Let us go to the questions. What are coherent sources? Question number 2, under what condition there will be constructive interference? Question number 3, what is meant by path difference? With this we come to the end of the lecture number 12. The rest of the things with regard to the interference phenomenon we will take up in the lectures to come. Thank you.